data structure, that is queues. Is the recording starting? All right. So as I said, we'd be covering nodes. Then we'll move on to data structures. In data structures, in today's session, we'll be covering queues. In queues, we'll be covering the theory part and then we'll code the actual queue. All right. So I'll just share my screen for the PPT. Yeah. So yeah, so guys, basically what happens in nodes, let me tell you, whenever we go for data structures in any language, there are, and in fact, not even in data structures, if we take any, for example, if we take chemistry, there are atoms that make the smallest part, isn't it? So even in data structures, we'll encounter some concepts that are the smallest building blocks and that we use further to make, more complex data structures as we go. So nodes is a very simple concept in Python. We'd be studying it. So this is the first data structure that you are studying. What happens in node is you can take node as a simple block. What a block does is it does nothing. This block just connects to the other block and it also stores a value. So consider, for example, there's a box. It has a wire attached to another box, and that box also has something in it kept as a value. So we know now that nodes are basically very simple boxes or fundamental building blocks in computer science data structures. These contain a value or some data, and also they contain a link to another node. So for example, uh, you can see in the right bottom corner, you can see a depiction of node where it has a data and then it connects, it has another link to node B, isn't it? So this is a very simple concept, guys. Now what we do is we use these nodes in different forms. For example, in trees, we'll use them in a tree format to make a tree data structure. For linear data structures, we'll use nodes to form queues and stacks and linked list and double linked list and all that. So when nodes are connected in series, we form data structures, isn't it? So whenever we have to specify that in a series, a node is the ending of something, the link to the next node would not be there. I mean, it won't be connecting to anything else, isn't it? So that node would be having link to null, the null link, or it would have no link. As you can see in the slide, there's this node C. It it is connected to node D and node E. The node D and E again have their data, and then they are not connected to anything. So that is the termination of a node. It is the series is being terminated. So are you guys getting the current whatever we just talked about, whatever we just learned about nodes? Are you guys comfortable with that? You must be very comfortable with nodes. Uh, Abhay, are there any doubts? You can just tell me now and we could just go on with it. Because the first 5 minutes we'd be giving to nodes and then we'll come to the functionalities. All right, so we'll go to node linking. Now in the functionalities, nodes have, several ways where we can manipulate them. For example, node A is connected to node C, and the node A has the value duck, node C has the value goose, and node A is connected, so we have a link to node C, and node C is the ending point. So we have no link, and hence we use the word null for that. Now, if we add a node B, we add a node B in between. Is my pointer visible? I don't know. There's this thing meeting in general. Anyways, if we add node B, what we'll have to do is we'll have to take two steps. First step is that we'll have to update node A, node A's link. That was previously it was showing or pointing to node C, but now it should point to node B. So this is the first step we need to do when we are making a new node or we are adding a new node in the middle of two nodes. So the first step we did was change the previous node's pointer or link. And the second step would be to obviously link the newer node to the next node. So the newer node is node B and we link it to node C. So in the link we say node C we are linking. Now what is the process to remove a node? Again, we have two steps. In Python, what we do is we first of all we again will change the link of node A to node C. Then we'll delete the node B. The best thing in Python is that when we do the changing part of node A, since node B is now terminated, since we've already set the link of node B equal to null, it will get deleted on its own. That is a functionality of Python 3 itself. It's called garbage collection. So that we don't have to do from our side. All right. So this is up with the nodes. We'll try to implement them through coding. A little bit of coding and very simple coding. Is this visible, guys? Is this ID visible? This is my Code Academy ID. Is this visible?
Yes.
Amazing. So we just delete this code. A lot of code over here. We don't need all this. All right. So let's focus over here. We define a class node over here. So those who don't know about the concept of classes and how to actually define them in Python can see right now. So in this IDE, first of all, I'm using this Code Academy IDE, but feel free to use anything. I mean, it works on anything. You could use PyCharm, or you could, use simple text editor as Atom or Notepad plus plus or anything like that. Jupyter works well. So we define a class node, a class name node. This is a syntax class, the class name, and a colon. Then we define the initial function that underscore underscore init uh, underscore underscore. This is one of the dunder methods. Dunder methods or dunder functions are those functions. Simply, you can remember dunder methods by the fact that the name itself says dunder. That means double underscore. D for double and underscore. So these dunder methods are what define a class usually. And in the init function, we have a self variable. So what is self? Now this is we are going to Python definitely, but let's do it anyway. So what self does is self is basically the node itself. Uh, until and unless we specify another node, we can use self to replicate. For example, Anmol we are making a node named node Anmol. So अभी तो बनाया नहीं है, but we want to use it, है ना? So, but before using it, we need to really define the functionalities. So to define those functionality, we use the self method, we use the self keyword, and we'll say कि अभी we'll use self. बाद में when we make a node, the self parameter will replace itself with the node's name. So nodes, as we saw, they have two parameters. One is the value, the data they'll have, and the other would be the link to the other node. So for now, I've set the link to another node as none on default. Now I'll use the self.value and set it to value, since this is the setting, and self.link node to the linking node, the next node. Now we need to really specify some methods, some common methods or some functionalities. So I have thought of these three functionalities, two get methods. You know, guys know about the get methods, I hope so. Get methods are basically methods that get you something. So we define two methods. Basically, first we'll define the get value method. Value method will use self as its parameter, and this get value method will give us nothing but the node's value. So it will return us the node's or self dot value. Clear up till now? The another the function that we are going to define is get link node. That is the tell me what the next link node is. So this is the next function that we define, and again we'll use the self parameter. And what do we return, guys? Someone can please unmute and tell me what do we return in the method?
The block
Can someone
Dot link node.
self dot link node? Great. This is the we defined our two getter methods. Methods or the basic functionalities of node. We can use them anywhere to make the data structures upcoming. Now we'll also define one set method to actually set the link to the next node. हम लोग value तो we can define when we are creating the node, but to set the next node, the link to next node, we'll define a method. So we'll define a method named set link node. And in this, the parameter would of course be self and also the link node that we want to add. So what this will do is it will set the self.link node equal to the link node that we have given it as an argument or parameter. Is it clear, guys, up till now?
So
Yes.
what's the difference between the previous function and this one?
The get link node just tells us that, for example, A is connected to B. So if we run the function a dot get node, get link node, it will tell us that B is the link node that A is connected to. But if we use set link node, we can tell A, for example, if we use A dot set node in bracket, we use maybe C. So what this function will do is it will change A's link to what C. So the set method is to actually set the link node that is upcoming next. We can set it. We can modify the link value. So I hope you got it now.
Yes.
Great. So now let's use them. We defined our three functions, three simple methodologies. So let's say I make a node Yakko, named Yakko. This is a node. I'm using the node class. And what parameters do we have to really give? We need to give the value, and we can give the link node. We can give, or on default it will set to none. है ना? So we'll just give the value for now. We'll give it a value. This is Yakko. Something, anything we can give. है ना? Let's define one more node dots node. Again, we can. This is lecture. All right. Now we use the setLink function. So we use Yakko.setLink, and in bracket, what was the setLink function? In setLink function, we give the parameter of the next link node that we want to link it with. So we give dot. So we give dot. Now what this will do, it will set Yakko's link. It will set Yakko's link to what? Dots. I don't know if someone is asking.
So Yakko and dot are just class variables.
Yeah, those are nodes. We have specified them as nodes. We have made two nodes, and now Yakko will follow all these functions inside the class node. So when we run yakko.setLink node, तो setLink node के अंदर जो भी हमने parameter दिया है, it will use that parameter. I'll see who wants to come in. I don't know. Thank you guys. तो इसने याकोस के साथ अगला लिंक काय का डाल दिया डॉट्स का. तो now Yakko is a node connected to dots, and Yakko has a value. This is the Yakko, isn't it? Now let's make a variable dots data. तो dots का data हम कैसे हम output कर सकते हैं? How can we do? We can say that Yakko dot get link node. मतलब Yakko से connected कौन सा link node है? That we can get from this function Yakko dot get link node. And now we know that Yakko से जो connected function है, that we know is dots. So this function, this whole function basically equals to dots, isn't it? Isn't it, guys? Are you getting it or not, or am I just going in and over your head?
तो भैया वो जो याको का वैल्यू था दिस इज याको इट गेट्स रिप्लेस्ड विद दिस इज लेक्चर दिस इज अ लेक्चर
No. Yakko has uska value, and it has a link to another node that is dots. Dots का खुद का वैल्यू है, एंड उसके आगे कोई नोड नहीं है, तो उसका जो अगला वाला लिंक का नोड का वैल्यू क्या होगा? नल. यू गेट दिस? इतना समझ में आया?
यस यस यस
So Yakko dot get link node, when we use this function, तो Yakko का get link node मतलब Yakko का get link कौन सा था? Link node कौन सा था? Dots.
Dot.
So we'll get dots. Now this function means dots. Now dots dot get value. So dots dot get value, what should it give? This is a lecture. So dots की value it should give, right? So let's try and run. Let's print dots data, and it should give this is a lecture. So it's given. Any doubts, guys? Any doubts in this? No doubts?
No.
All right. So now we basically know what nodes are, isn't it? So now we'll move on to our actual data structure. We make a data structure named as queue. So queue is one of the linear data structure. And what do you know about queues? Queues, what basically happens is, in a restaurant, for example, there is a queue. People come in. It is kind of a line. It is a straight linear line. People come in, they join at the back, and they come out from the front. So it is a first in, first out. The one who comes first gets to get out first, That is what happened in a queue, right? Isn't it? In a hotel or restaurant, in a waiting line, the person who came first gets the chance first, right? So that is the same what happens with queues. Now, this is what we know about queues, that these are simple lines. These are simple linear data structures that give that run on the function of first in, first out. This is it. Now, what are queues made up of? So we can make queues from nodes. See, this is a queue. We can, we can connect several nodes to make a single queue, and then we can uh, give each node a formal value. For example, A connected to B connected to C, and each queue could have a value, and then it would be connected to the next node, isn't it? So we can use nodes over here, and we have three functionalities. Like for the use of queue, we have three functionalities. First functionality is Enqueue. What an Enqueue does is it adds to the queue. And whenever in a line or queue, where do we add? We add to the ender. So if you see in the right corner, there was a queue which contained Bob and Anne. We enqueue Charlie, so Charlie gets to the end of the queue, right? Then we come to the second function, that is dequeue. What dequeue does is it removes the first character or removes the head of the queue, because the head would be the first in, so it will remove the head. So what gets removes and gets removed when we use the dequeue function on the. And then we have the simple third functionality of queues, that is peek. So what peek does is peek simply shows us that who is standing first in the line, who is the head of the queue. So Bob is the head of the queue since we already removed Anne. So do we have any doubts in queues up till now? Any doubts? What queues are, how they work, any simple doubts that you
So
can
in
have?
peak
Yeah,
functionality, what will so how will it function? Like the person who has been DQ'd will see the overall functioning of Bob, or Bob will see the functioning of the one that has been DQ'd?
it will see the overall function. See, there's a queue named queue at the whatever hotel name you can take, queue at VIT Bhopal. Now, there's a list of people around. When we use the enqueue function, we have to specify that we need to enqueue this person to the queue. So it will add to the end of the queue. When we dequeue, we need no parameter. It will simply, if we just have to say that dequeue the list, and the list will remove the head participant. When we use the peek function, we again have to give no parameter since it will simply show us the head method. So in queues, we have a head, we have a tail, we have in between characters. Enqueue adds to the tail, DQ removes the head, and peek shows the head. So are we good now with the functionalities of queue?
Yes.
Great. Now in queues, there are two corner cases or problem cases what we encounter usually. That is the underflow and overflow. You've heard stack overflow, no? That overflow we have in queues and underflow. What they mean is overflow, what it basically means is when we have a queue of a specific quantity, that we call it a bounded queue. So when we have a bounded queue and we add to, like for example, there is a queue of 10 participants and we try to add more to it, it causes an error called overflow, queue overflow. So that is basically that the queue is already full and we are trying to add All right. Then what is underflow? For example, there's an empty queue and we try to use the DQ function on it. So since it is already empty, how can we remove someone from the queue? Isn't it? So that is what called is the underflow problem. So these are the two corner cases that arrive in queues: queues overflow and queue underflow. So now we'll go on to the implementation of queues. Uh, and we'll try to implement the three functionalities. We'll make a queue basically. Simply, we'll design a format of queue as we did for nodes. So we'll do the coding part, and after we complete with the coding part, we'll have a short quiz or something like that to just check your concepts. Now see, for queues, we'll be using the node class that we made already. We made the class node, right? We have the initial definition. We have the set next node function. We have the get next node method, and we have the get value method. Method or function go interchangeably. There is a fine line between them, but you need not understand it. So we'll define a queue and let's see how it goes. And feel free to just stop me at the exact point you have doubt. Just unmute and speak. So from node, we imported node. We basically imported the node class so that we can use it over here. We made the node class, right? This is node.py. We made from node, we import the node class that we defined. And now we can use all these four functions. So while defining a queue, what we need to see is when we are defining, we need to form a head, we need to form a tail. And in the initial, since we are giving it no value, we should allot them a none value. So that is what we've basically done over here. We've created an initialization definition using the init function. Again, we are using the self method. Self.head, and we've given it a none value since the queue is right now empty and there isn't any head or tail value. So same we do for the tail. Now what were the three functionalities, guys, that I told you just 2 minutes ago? Can anyone unmute and tell me?
Q, DQ, and peak.
Q, DQ, and peak. NQ, DQ, and peak. Right. So we'll implement the peak value. So what the peak value does is peak value takes a parameter. It takes no parameter. So we give it a self parameter. Parameter that every thing should have, and then we simply return self.head. Self.head will take us to the head of the queue, and then get value function will give us the value of the node. So this line self.head.get value, what will it give us? It will give us the value of the head node or head element in the queue. So this is the first and the easiest functionality that we defined successfully for queue. We've defined the first functionality. Now coming on to the second functionality. What was second functionalities? Enqueue and DQ, the other two functionalities. But before going to them, we will define some small functions that we can use to define Enqueue and DQ. So for that, I'd be using the size variable. What the size variable will do, it will tell me the size of the queue. It will simply tell me the size of the queue. Second will be the max size. Max size, what will it do? It will tell me what is the max size of a queue and how much space do we have actually left, so that when we add elements to the queue, we do not really, do the overflow thing that we discussed. The third thing that we do, these are the two variables that we have. All right, so let's just do it, है ना? In the initial definition of the queue itself, I'll make two variables, self dot size, that is q. Take the self as q. So q dot size. What would be the size of q? For now, it is 0, है ना? Also, the second variable self dot max size. So q dot max size. Basically. What is q dot max size? It would be some max size of the queue. Anything that we give it, basically. We'll also add it to the parameters since we'll be giving the function what would be the max size. And for the beginning, so that it does not shows any error, we'll set it to none. So these are the two extra variables that we added for our queue implementation. Now I want some simple methods. The simple methods as by mean the ones we implemented in Node. I want some simple few 2-3 methods also. So the first method that I want is diff. I'll just speak them out first. First method is get size. Get size, what will it do? It will tell me the size of the queue. So let's define get size method. Can someone tell me please that what will be the parameter or what will be the argument that we take here?
Self.
Since it has no other value to be taken. And what will it return to us? The size. So
Max
what will
size.
it self dot size? Great. Going next, I want to define a function that tells me if the queue is empty or not to solve the underflow problem. So I'll define a function is empty. Empty. Again, there is no no parameter needed. What it would simply return me, what will it return me is if the queue is empty or not. So let's little another way. If the size of queue or the max size self dot size, if it's lesser than 0, that is currently the queue is lesser than 0, then it will return me true. All right. Else, it would return me false. Pretty clear over here. Are we clear over here? Any doubts with the empty function?
Is it guided by the concept of indexes?
Yeah, we have to use the indexing if I'm correct. Indentation, are you asking, or indexing?
Indexing.
Um, Not really, because we aren't actually indexing something over here. We are simply this is not array or something. We are simply taking nodes 1, 2, 3, 4, 5, 6, 7, 8 nodes. There is no zero node or something. There is node 1, 2, 3, 4. So there is no indexing as such. The size will simply tell us the size of the queue, and if it is lesser than 0, then the queue is empty. So we'll return true. If it is greater than 0, then it will return false since the queue is not empty. So
भैया
what
size lesser than 0 कैसे होगा?
size lesser than 0 cannot happen actually, because there cannot be negative nodes, but just in case taking, we can remove it also. Someone has some chat box message. Actually, I thought you guys have studied Python in semester 1, but no worries. This is the variable initiation we are studying. I already taught you the self method. And if you have any doubts, you can just ask me. Whatever doubts you have, even if it's not even from Python, you can ask me. All right. Um, so this is a simple function. What function in maths you can take? Function or method we call them. What do function in maths do? We give them an input value and we get an output value. So the is empty function takes only the self or the q as an input value and gives us the output as true or false depending on if the q is empty. So um, Anand, if you have really any doubt, you can just ask me. I know how teachers skip the topics, and I know how you must guys have studied Python in the first time, but it's all right. You can ask me anything, really anything. All right. So we did the get size function, we did the is empty function, and now we can go for the third function, that is has space. We can we can create any name, huh? Has space ki jagah I can use any name other also, but I'm just using so that it's very clear. So has space function is very simple function. We'll check if the queue has space. So to check that, what we can do is we can check if self dot, that is the queue, dot max size is equal to none. Then what will it do? It will return true. Agar max size is not fulfilled, if it's not achieved, then it will say that true. The queue has space. Else, what will it do? It will return. Check the indentation first. Dot max size is greater than self dot get size. That max size is greater than the get size. And the queue is full. So this was the has space function does. Are there any doubts? We can move on with the actual functionalities now. Now that we have our preliminary functionalities, we can move with the actual functionalities. The mainly the Enqueue function and the DQ function. So now coming to the Enqueue function, guys. This is the interesting part now, and listen to me carefully. All right. For the Enqueue function, we need to take three cases. Yeah. So for the Enqueue function, we need to take three cases. The first case should say if the queue is full. All right. If the queue is full, that then basically we cannot enqueue anything. So we'll check if the queue is full, then we'll output that you cannot add anything, and try again later or something like that. The second thing we should check is if the list is already empty, or if the queue is already empty. So if the queue is empty and we add an element, what we have to do is we have to set that element to the tail as well as the head. So that new element is the tail as well as the head. So if this happens, that the list was earlier empty and now we enqueue some element to it, the tail and head are being set. The third case is that if the list has another nodes already, like it is a general queue that has some other elements already. So what we do there is we simply make the general changes. We make the simple general changes of adding a node. That is what we do is when we enqueue, we make the new element as the tail, and we remove, we change the previous tail element. So let's see. So again, yes, there's some, anyone has doubt? Alright. We'll define the enqueue function. What the enqueue function will take inside it? What will it take, guys?
Self
And it should
makes
take the
sense.
value. No, it should take the value. If you are adding something, then tell me its value also, na? Tell me its name or value, something you need to know. So, बाकी सब we can already use from here, whatever is needed. So we need to take care of the three cases that we just discussed. First is if it has, if it has simply space. If the queue has space. If self has space, then we'll do blah blah stuff. अगर नहीं है, else, what else means that the list is empty. So we can print something like that. Queue is full. Sorry. Isn't it? This is simple. We dealt with the first problem with enqueue. है ना? Now, if it has space, then comes two questions. Is the queue empty? So if it is empty, then we'll do something. So let's make a variable, first of all, item to add. This is the item that we will add to the queue. And we set it node.value. We make a node of that item basically. You know? I think this should be clear, or else just ask me. So what we just did now, it had a space. So we added that item as a node with value, whatever value we want. You know? So we can now just print that we added what? Added an element or something like that. So I just say that clearly. Item to add key get value. So this is just I'm doing fancy stuff to actually tell key, you know what to bring the better user interface. So when I add this, see if it has space, it will simply add it, and then we need to take care of those two things that we discussed. So we've added it. Now if the list is empty, we'll take care of the first thing. If the list is empty, so we can use now the self empty function is empty. If self is empty, if this is true, that means it is empty. What we'll do, what we have to do, guys, what we had to do, someone tell me. If the list was empty,
We have to
we
assign to both head and tail the
We have
same
to
value.
assign it the head and tail.
exactly. And where have self.head, head, and self.tail, and we assign them both to the same value of item to add. Item to add is the item that we add, basically. So we set them to item to add. This is clear up till now. You know?
Yes.
If it is not empty, if it is not empty, what did we do? If the queue was not empty, what did we do? The
भैया
item
एक
was
क्वेश्चन,
added. हाँ, please.
भैया वो लाइन 30 में प्रिंट
हाँ,
उस प्रिंट
हाँ,
एडेड प्लस स्ट्रिंग item to add डॉट गेट वैल्यू, तो मतलब ये
हाँ,
वैल्यू देगा item to add की,
हाँ, आइटम टू ऐड की वैल्यू देगा.
तो
तो
नीचे
अपन
32 और 33 में क्यों नहीं किया ऐसा?
32 हम लोग देखो हमने ऐड कर दिया आइटम. हम लोगों ने ग्राफ यूजर को बता दिया कि वी एडेड दिस वैल्यू. बट अब ये बताने की तो हमें जरूरत नहीं है ना, वी कैन डू दिस इंटरनली. तो इफ वी वांट टू शो, तो वी कैन शो इट कि print करके हम वी कैन टेल इट कि we've added it to the head and the new head is, you know, item to add. We can show it, but there is no need. It could stay hidden. What we needed to show was कि successfully add हुआ कि नहीं क्यों में. तो we showed it by this, है ना?
हाँ ओके भैया.
Now if वाला वो पार्ट किया, अब else वाला पार्ट करते हैं कि empty नहीं है क्यों. अगर क्यों empty नहीं होती तो we added the new element to the tail, so we have to assign the tail to the new element, है ना? तो we'll say self dot tail. First of all, self dot tail हमें इसका नेक्स्ट नोड था, जो जो टेल थी पुरानी वाली, उसका जो नेक्स्ट नोड है वो आ गया अब नया. तो उसके लिए हम नोड का फंक्शन यूज कर लेते हैं, सेट नेक्स्ट नोड फंक्शन याद है ना? सेट नेक्स्ट नोड, और हम इसमें वैल्यू कार्ड डाल देंगे आइटम टू ऐड. आया समझ में? इट्स वेरी वेरी सिंपल.
Yes.
है ना? एंड अब हम जो नया सेल्फ डॉट टेल है उसको क्या कर देंगे, आइटम टू ऐड अगेन. पहले आइटम टू ऐड को हमने लास्ट टेल की वैल्यू सेट की, मतलब नोड को, इस लाइन में हमने नोड को लिंक किया है एंड इसमें हमने टेल की वैल्यू सेट की है. एंड फिर हमने साइज भी बढ़ा देते हैं, सेल्फ डॉट साइज, जिससे साइज वेरिएबल भी हमारा अपडेटेड रहे. तो सेल्फ डॉट साइज इक्वल टू 1. तो गाइज दिस इज इट, वी डिसाइडेड दैट एनक्यू फंक्शन. हमने तीनों जो भी प्रॉब्लम्स थी वो कवर कर ली एंड वी डिड द एनक्यू फंक्शन. नाउ विल कम टू द डीक्यू फंक्शन. अब अगेन डीक्यू फंक्शन में भी वी हैव 3 केसेस टू दैट वी हैव टू हैंडल and we'll just cover it very quickly now, है ना? Now you guys know. Do we have any doubts in the enqueue function? Sorry, I forgot to ask. Any doubts in the enqueue function? Line by line, is the code clear? Why
Bhaiya,
each line is clear?
can you explain the else part?
This part.
Yes,
See,
sir.
if the list was not empty, अगर list empty नहीं थी तो हमने tail में we added a new value. We added it to the tail. तो हमें tail को modify करना पड़ेगा. तो we said the tail value should be equal to item to add, है ना? This line is clear. Line number 37.
Yes, 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 yeah.
Line number 38 is also simple. We added we incremented the value of size क्योंकि अब हमारा size बढ़ गया. Now line number 36 में what we do, हमारा पुराना tail जो था उसका हमने next node, मतलब अब जो new tail आने वाला था उसका next node को हमने link किया है. तो set next node we use the method from the node functionalities that we had. तो what it will do is जो भी tail था self dot tail उसका next node what it would set item to add. So this is the linking, this is the linking, and this is the assigning. तो पहले हम link कर देते हैं फिर assign कर देते हैं क्योंकि if we assign this then we'll have to do other stuff. Is it clear now?
Yeah, it's clear now.
Now coming to DQ. So DQ में again hardly 10 minutes guys, please stay focused. Just 10 minutes. DQ में function में we have another 3 cases. अगर list empty है तो we cannot DQ because that will cause the underflow criteria, right? So we have to tackle the empty part. अगर empty है तो we cannot do DQ. Let's do it simultaneously. If the queue is empty, again DQ में भी self लेगा, बस self ही लेगा इसमें क्योंकि DQ तो happens automatically, it removes the head. तो we'll see if self dot size, if the list size is greater than 0. अगर लिस्ट साइज ग्रेटर देन 0 है मतलब लिस्ट में कुछ कुछ है तो हम वो रिमूविंग करेंगे. अगर नहीं है, if the list is empty already, तो we'll print a statement. List is queue is empty, cannot dequeue, है ना? Cannot dequeue. तो ये हमने फर्स्ट अंडरफ्लो वाली प्रॉब्लम कवर कर दी. Second problem, second thing that we have to consider, not actually a problem, is that if has one element, अगर सिर्फ वह एक एलिमेंट था पहले लिस्ट में, तो what happen will now, अब वो एलिमेंट हमने निकाल दिया, तो अब हमें जो न्यू हेड एंड टेल की वैल्यू थी हमें फिर से नल सेट करनी पड़ेगी, राइट? सो लेट्स डू दैट. इफ पहले हम आइटम टू रिमूव भी स्पेसिफाई कर देते हैं. अब आइटम तो रिमूव कर ही रहे हैं हम, क्योंकि साइज 0 से बड़ा है, मतलब एक ना एक एलिमेंट है, तो वी आर रिमूविंग एन आइटम दैट इज अ नोड with some value, that is a node. And node कैसा है वो, या नोड भी क्यों करना, इट इज ऑलरेडी डिफाइंड, सो इट इज द हेड. तो हेड को हम रिमूव करेंगे तो आइटम टू रिमूव विल इक्वल टू हेड. तो हमने ये रिमूव कर दिया, तो वी कैन प्रिंट हेड इज रिमूव. नाउ क्या हमें प्रॉब्लम थी कि इफ उसमें एक ही एलिमेंट होता है, इफ द क्यू हैड ओनली वन एलिमेंट, if size self dot get size function we can use. See, we are using our functions only, हम किसी python की उस library use नहीं कर रहे. We are using our functions. If get size equal to 1, then what we have to do, self dot tail and self dot head को हमें फिर से none पे set करना है. You have to set them to none. Is it clear? And अगर वन नहीं है, if it is simply normal queue with more than one elements, then we can simply say कि अब जो next head है वो इस queue का अगला वाला, मतलब जो second element था वो अब head बन जाएगा. तो self dot head will be equal to क्या, self dot head जो पुराना head था उसका नेक्स्ट नोड. तो उसके लिए हम क्या फंक्शन यूज कर सकते हैं, गेट डॉट गेट नेक्स्ट नोड. ये समझ में आया लाइन?
अनमोल.
हाँ.
हाँ
हेलो.
एक्चुअली. हाँ अनमोल, अनिकेत
Yeah.
this side. हाँ
Hi
अनमोल, I have a
Anik.
doubt. I have a doubt, like in DQ element is removed from tail or head side.
It's removed from head.
Okay.
The head element is removed, so we have to specify the new head element now. Alright. So I hope line number 51 is clear. And now we can simply, we've covered all the cases, we can say just the size is -1, self dot size only. Size we have to decrease, right? We dequeued something. Size we've done, and we can return whatever. We can return something if we want. Otherwise, we can return the item to remove. That is also if we want to. Get value item to remove key item. So we have successfully created the DQ functionality in our queue. So we created the peak, we created the enqueue, we created the DQ. If you have any doubts, we could just check on them.
Yeah.
Yes.
Here in the line 45 and 46, we have removed the value from the queue.
Yes.
So
हमने
in line
45th में ही remove कर दी. Yeah. Yes. You can put it in the chat box अगर कुछ वो technical errors है ना, we can cover it.
in the 47th line, why will we check the value is equal to
I really didn't get you. um,
1. It would be 0 only. Saying that if the value is removed in line 45 only, so
can you type your doubt? Just can you type it out? So, guys, we are done with the implementation, the code implementation of queues, and now we can run them. We can really run them if you want.
भैया
For example, yeah,
पहले डिस्टर्ब नहीं करना था बट लाइन नंबर 14 में एक इक्वल टू साइन मिसिंग है
14 में sorry, yes. uh, we can make a queue or something like that if we want to. Maybe home list equal to we can create 5 length 5. Now, if we want to enqueue, if we enqueue something, so homeless.enqueue use home, smaller variable home.enqueue use something salad. We can enqueue a few more things. Mango or something like that. And we can print to see what home gets us. Line number 22, we have some error. Have some petty errors. Print comma, I don't know. I'll just get it corrected for once and we can do it. Till then, I'd ask you guys to do a simple quiz that will check your understanding and it will give you the marks also right now at the moment. We haven't
so will you
removed
please
the
share the code and the PPT along with the cheat sheet?
Yeah, sure. I'll share all the three things. Uh, I'll share it on the Teams, you know? Share it on the
Okay,
Teams.
okay.
Please, guys, try the quiz and ask me if you have any doubts regarding the quiz questions so that I could clear them right now. And we are basically done from my side. Um, although I'll just debug that code that we just saw, and if you want to see implementation of queue that we could do. All right, so just do the quiz. I'll close it after 10 minutes and just let me know the results. All right. So, are we doing the quiz right now? Hmm. Yeah, actually, I had to restart the server. It's causing some problem. So we simply made a queue, home equal to Q5. We enqueued salad, mango, and pea, and we dequeued twice. So salad was removed, then mango was also removed. That's how we basically do it. So if I add salad first, so salad is removed first. Like it's pretty simple with the queues. So did you guys like the event? Like this workshop, I should not term it as event, but like this workshop.
Bhaiya, it was good.
Uh, did you get it, the whole thing? Like, will you be able to implement the whole queue after this? Like, after.
थोड़ा brush up करना पड़ेगा syntax वगैरह,
After a little practice, we can implement it.
but concept समझ में आ गया.
Great. So we did it in 1 hour. All right, along with the quiz. If you just do the quiz, if you have any doubts, you could just let me know. I'll share the uh, cheat sheets over here. Here are the cheat sheets, and well, we are done with it. Then. Thank you, guys. Thank you for coming. It really means a lot that you came and stayed all the way through the 1 hour session. And probably I'll see you again. Thank you.
Thank you, Bhaiya.
Mhm.